Hello, why did the man give his dead batteries away? It's because they were free of charge. Ha ha ha. Okay. Today we're going to continue on with this functions, relations, and graphs topic. In particular, we're going to talk more about what exactly makes a function a function. We're going to talk more about what it is. I know the last video we did, but it was more about the notation. Today is about what they actually are. Okay, now everything that we can kind of write with y's and x's in mathematics becomes a relation because you're relating two things together. It's telling me how y interacts with x or how x interacts with y. Okay, but we're going to do this thing called the vertical line test. And basically everything is a relation, but if it passes the vertical line test, it means we can call it a function. So if you can kind of see, I've got a little flow diagram. So if it passes the vertical line test, boom, we become a function. If it doesn't and it fails the vertical line test, then it's just going to be a relation and we'll call it that. So we're learning to classify today. Okay, now using the vertical line test is as simple as this. All I'm going to do is I'm going to draw a bunch of straight lines and maybe I'll make them a bit thinner so it's not so thick. So I'll draw a bunch of straight lines on these graphs here. Now, as I draw a straight line, each time I cut the graph, at most, I'm only ever really going to cut it once. That means it passes the vertical line test, therefore it is a function. Okay, and let me show you what I mean. Now, in this next one, if I did the same thing, I can see here immediately, not only do I cut the graph once, but I'll cut the graph twice, which means it's not one-to-one like we talked about last video. It's actually for one x value, we actually have two y values. Okay, so in this case here, it does not pass and it's not a function. So in other words, we just call that a relation. Okay. Now this last one here, have a go, take a guess before I go through it. You are correct, I hope. It is not a function because it cuts more than once when I draw a vertical line, hence the vertical line test. So we call that one a relation as well. Okay, now there may be some other things that we need to talk about. We start talking about domain and range when we start talking about functions. Okay, now domain very simply has to do with the permissible. I call them permissible. You can call them allowable. It just means they exist there. So I call domain your permissible x values, and then range is the permissible y values. Okay, so if I'm stating the domain and range of these two graphs below, let's take a look at what possible x values and y values exist. So the way that I would kind of go about my answer is I would say, okay, let's write D for domain. And what I'd say here, I'll take a look at the x and I'll take a look all the way across. And I can see, yeah, at every point of x, I know I kind of haven't drawn it the whole way, but for every x value, I will have my graph. My graph will exist because I know that's going to go on until infinity. And I know that's going to go all the way until negative infinity. And so I'm always going to have some sort of x value. So in this case, the way that we would write it is we would say, you would write all real x. Okay, or sometimes what they'll do is they'll say something like this. For the domain is going to be between negative infinity to positive infinity and not including. So we use our curved brackets. Okay. Now our range is a slightly different story. Now, if I look at my y values, it's going to be these guys here, my y values. Now, if I take a look here, my function doesn't exist at every y value. I've got my function that exists there, but then at some point, and I should have drawn them as straight lines so I don't confuse you. Okay. Now it's not a horizontal line test. I'm just showing you that at every y value, something exists until that point there. Okay, now there's no function down here. Okay, my graph doesn't exist down there. So, and I can see here that my graph is going to go up forever this way and up forever that way. And so from here, we can kind of see this is how I'd write my answer. just kind of cleaning that up. I can see here that for my range, my y values have to be greater than or equal to -4. That's where my function or my graph exists. It's allowable there. If I was to write this as using the bracket, the interval notation they call it, I can equal -4. And -4 is the smaller number, so I'll write it on the left, and I'm going to use a square bracket because I can equal. And then it goes to infinity, so, and you can't ever really equal infinity, so they'll give it a round bracket for the infinity. Okay, hopefully that's making sense. Have a go at question B, see if you can do it without my help, see if you can state the domain and range. Okay, so hopefully you gave that a go. If you didn't, boo, pause the video, do it again. If you did, pause it and you tried it, good job. Let's talk about this one. For the domain here, we can see that this graph only really exists for values of x where it's greater than 2. So in this case, it's going to be nice and easy. X is greater than or equal to 2. And how do we write that in our function notation or in our interval notation? Well, that means 2 is our smallest number and infinity is our largest number. Can't equal infinity, can equal 2. That would be our answer. Now, in terms of our range, I can kind of see here as well that I've only got my function exists all the way up here, but it does not exist down here at all. I'm sorry, those are just crosses. So in this case here, I can kind of see, maybe I should do it this way. Those are going to annoy me. So for this one here, I'd write something like my range exists for when y is greater than or equal to 0. And so my range goes from 0 to positive infinity. Can equal 0, so square bracket, can't equal infinity, rounded bracket. Okay, so that's how you would do it graphically just by looking. Now, sometimes you're going to have some questions where you're not given what the graph looks like and they're kind of semi-tricky to graph, and we don't know how to do those yet. So what I want you to have a go at here is just understanding what happens in a bracket and what happens in a fraction. So if I'm looking at a bracket and a fraction, the square root, whatever is under here, a has to be greater than or equal to 0 because you can't have a negative under the square root. Okay, so in other words, the way that I could think about this is, okay, x, if I'm talking about the domain, I'm talking about the x values. So x minus 3, whatever's under the square root, must be greater than or equal to 0 because I cannot have a negative number. And so from here, you can kind of see very easily, I can solve and I can see that x needs to be greater than or equal to 3. And if I wanted that in interval notation, it'll be 3 to infinity, can equal 3, can't equal infinity. Okay. And in terms of my range, this is where I have to think here. Y is here, and it's saying that y is the same thing as this guy. Now, if I've got a square root and there's no plus minus out the front, it's just a square root, we assume it's the positive. So there's nothing in that, the square root will never be negative in this case. So in this case here, all I'd say is, okay, y has got to be greater than or equal to 0. Okay, because a square root will never be negative. So that means it's always going to be a positive value or 0. Okay, so that's how we would do that question there. If it's greater than 0, again, can equal 0, can't equal infinity, but it goes from 0 to positive infinity. For this one here, I want you to recognize what happens in a fraction. Big important thing here, your fraction denominator. Okay, just remember your denominator cannot equal 0. Okay, so your denominator will never equal 0. So in this case here, I can kind of see, okay, well, my x value can't equal, well, if I want to, I'll just take my denominator, which is x minus 1, and I'll say, okay, that can never equal to 0. And because I'm talking about the x value, I'm going to call this my domain. And here, I'm just going to solve very similar like I would, but instead of writing equals, I say can't equals. And I can see that X will never equal to 1. So that is a restriction in my domain. So the way that we would write this is, I can have everything from negative infinity up until 1, but I can't have 1 and I can't have negative infinity. And then I'm going to go and it's going to be, I have to be greater than 1, but less than infinity. So it's, you can kind of see because of these double closed brackets there, or like the closed, the curved on one side and the curved on the other, it's saying that it's all the values of X except for 1. Okay, I cannot equal 1. And then for your range, this is where you kind of have to be thinking outside of the box here. Range is talking about the Y, so I'm going to look at the Y here. And I'm going to take a look with a fraction. The thing that you need to understand about a fraction is, that's Y, isn't it? A fraction that has a non-zero number up the top will never equal 0. So in this case here, Y will actually never equal to 1, because whatever I picked as my denominator, I'm never going to make this fraction, oh, sorry, I lied. You can make it equal 1, but what you can't make it is, you can't make it equal to 0. Okay, you can make X a really large number here, or you can make it a really, really big number here, large or small, and this value will never be 0. It could be really close to it or really far, but it will never be 0. That's why here Y can't be 0. And the way that you'd write this one is very similar to the one before. I'll have all the values from negative infinity up until 0. And I'll have all the values from 0 to positive infinity. But I'll use the curved brackets because I cannot let it equal. Okay. Just in case you were a little bit confused, maybe what I'll do is I'll go back up here and just talk about the, okay, that there is talking about less than or greater than. And then if you have the square brackets, it's talking about these ones here. Okay, less than or equal to, greater than or equal to. Okay, so hopefully that helps. All the best, good luck, and make sure to ask questions when you have them. I'll see you guys later. Bye-bye.